here today to discuss the IBM Environmental Intelligence Suite with the Vegetation Management add-on, and working with Capgemini, our good partner, how we're bringing AI-driven insights to the electric utility market and beyond. And there's quite a bit to talk about. And I want to introduce both myself, Robbie Berglund. I am the Energy and Utility Global Business Executive. It's kind of a fancy name for the manager of the group that does things weather, environmental, remote sensing. And I want to introduce my colleague today, Jim. Jim, you want to introduce yourself? And you're going to have to take yourself off mute.
Yeah, I'm Jim Sokolowski. I'm a principal technical consultant within the data science and analytics arm of Capgemini. My bachelor's is in experimental physics, PhD in astronomy, astrophysics. I've been doing imaging stuff predominantly of the Earth for about 25 years. A lot of that work in vegetation.
Okay, great. So basically we're joined by Jim, who's a deep subject matter expert on the topic. I've been in the weather business for almost 20 years now and environmental factors and things. So we got, quite a bit to talk about, and I think you guys are going to enjoy the content here. So let's get started. And what I want to do is just begin with something that probably most of us agree with, that bad weather is difficult to mix with trees, utility lines, and poles. It causes a lot of outages. In fact, there's a study that says, look, 2/3 of all power outages are caused by the mixing of vegetation with utility lines and poles. And of that, there's probably about a little more than half or 2/3 where weather is the culprit behind that. And what we're trying to do is to keep our customers out of the headlines for some of these things you see here, right? The absolute monster major storms. In my business, what most of us recognize is that it's not necessarily the mother of all storms that's causing problems. More and more, it's fast-moving fronts. It is pop-up convective thunderstorms that are causing high winds and heavy precipitation and soil moisture load. And trees behave badly under those conditions. And when it comes to vegetation maintenance, that matters. Especially because our utilities that we work with right now spend quite a bit of money and time and resources trying to mitigate and manage really a wide variety of conditions here, all kinds of different tree species. Some of those are healthy, some of them are not. Mixed in with some of the environmental factors I talked about. Is it dry? Is it wet in the ground? Are the trees covered with snow? If so, is it wet? Is it ice? Or is it dry? And then, of course, other conditions, flooding, wildfire, kind of these climatic type layers that ultimately get the utility to try to solve, I would just say, the most popular or top 5 types of use cases or pain points across the bottom. Right now, most utilities are still cycle-based. They go to an area every 3, 4, 5. I've even heard as long as 14 years before going back to an area for vegetation maintenance. And mostly what they would say right now is look, we've really got nothing to tell us inside this vast territory what's really happening other than our cycle and, of course, driving around. And so to get those insights, they're very manual or they're expensive. Most of them would say we want to optimize contracting. The next 100-mile project that we put out for bid, we're not really sure if it's all 100 miles that need the exact same maintenance. Maybe it's only 32 of those 100. Okay. Next one is how the C-suite and executive leadership gets involved. What can we do with this program that we've got, the budget that we've been given for vegetation maintenance, and the time that we've got to reduce tree-related outages? So if there's anything that we can do to improve those metrics, safety, we want to do that. And there's technology now to help leverage to do so. Many, depending on where you live, and it's different just about everywhere you go, are trying to deal with problem species in a variety of ways. Sometimes it's because it's an ignition source for wildfire. Sometimes it's because the tree is so tall and it's over, it's what they call a fall-in risk, meaning it's tall enough to fall into the right-of-way. Sometimes those trees behave badly when it's wet enough, okay, or when the wind is from a certain direction. It's a lot for the human brain to keep up with these days. And then last, but not least, we want to serve our customers well. We want to keep the power on. And if we can, we want to keep our workers safe, right? If we can eliminate another helicopter flight or boots on the ground to get this kind of insight, then we will do so. Okay. So when you come to think about it, I mean, sometimes it helps to put this into story context. I'm from Austin, Texas, and I swear we have seen, just about everything. On the left-hand side, I was part of the Bastrop fires. I was a guy standing up on the roof of my house with a garden hose, trying to, water things down, just in the hope that, things weren't going to catch fire, and it was very, very close. And obviously, utilities do not want to be associated with this, and we want to identify the areas of our network that have high encroachment of vegetation. At the same time, environmental factors are saying this is a high risk, not just because of encroachment, but because you've got dry conditions and high winds, right? Ripe for wildfire. Let's flip the coin. You think about other conditions. I was also part of the February, I guess, depending on where you're at in the US, the Ice-mageddon, the Snow-mageddon event down here in Texas. I mean, it was absolutely horrific. This is my backyard. That's actually me standing there cutting yet another tree down that had broken in half because of the weight of about an inch worth of what they call radial ice. Okay, so on a circular surface, it builds up, and of course, it weighs down the tree, and that tends to make contact with conductors. And that's an environmental factor that we can calculate and we can bring into the type of technology that Jim and I are going to share with you a little bit today. So I want to hand it over to Jim just for a second, because part of the problem with gaining this kind of insight is just the robustness of data. So take it away from here, Jim.
Yeah, in fact, one of the common themes of everything we do data science and analytics wise is just the overwhelming amount of data in the world today. This cuts across every vertical, including the utility sector. And you can see a graph of what the worldwide volume of data is. If you can plot it in any way you want, whether it's the total volume or the amount created every day, it's really truly overwhelming. And few companies are really handling that data super effectively and doing a great job of it. The good news is, though, that as data volumes increase, the underlying architecture and technology to handle that data, things like cloud storage or acquisition systems, data handling systems, and exploiting the data, those things are getting better as well. They're getting better, faster, and cheaper. And the key to the data is, in fact, making winners and losers in virtually every industry we talk about. So if you can go forward here, Robbie. And again, the key to cost-effective data use is all these underlying technologies. There are rapid developments in cloud storage and processing. The techniques of data science and analytics are really, really ramping up quickly and keeping pace with the data volume as well. And key among these are the machine learning and artificial intelligence techniques that allow us to tackle even the most complex demands, the highest amount of data, and really make effective use of what we have. So if you can go to the next one, Rob. And again, this cuts across all business verticals, and those that are exploiting the data are really thriving. We see it a lot in the healthcare industry, where pharmaceuticals will be doing things like protein engineering using data science and analytics, machine learning, AI. If you think about how the COVID vaccine can actually be rolled out in something like 12 months, it's nothing short of a miracle, but a lot of that is the data science and analytics that went into engineering proteins and doing what are called adaptive clinical trials to test these things and make them ready for use in a very amazing time. Insurance companies are doing the same thing to mitigate their risks going forward, making sure they can track things and save money where they need to and pass these things onto their customers. Transportation is almost a no-brainer. We see what autonomous vehicles are doing, what drone delivery of packages is doing. And related to veg management for utilities is also the agriculture sector, where weather data, soils data, and remote sensing and analytics are all combining to increase crop yields and reduce pesticide usage, and enabling that true environmental stewardship to save everybody time and headache going down the road. Next slide, please, Robbie. For the utilities distribution and transmission segments, one of the key factors here is that satellite and drone-based imagery is increasing at a rate to keep pace with all the other things, the other data volumes, the needs, and so on. And we combine these with cloud analytics and AI to deliver an opportunity for infrastructure management. The graphs just show the number or amount of satellite data available to support these applications. They've been growing for decades, ever since I got started. They continue to grow. Another huge development is the increase and improvement in the drone market segment. The ability to fly drones to acquire data over remote areas reduces risks to people, makes operations far more cost effective, and can deliver just as good data on a time scale and a location that is really needed by the customers at large. So these things are really fueling a real opportunity in the utility segment. Next slide. And that's you, Robbie.
Yeah, okay, and I'll take it from here, because what we want to introduce is what IBM has labeled the Environmental Intelligence Suite. And this is a suite of integrated applications, and integrated is a good word because these the four pieces that you see on the left here, weather data, geospatial analytics, the ability to visualize and move that information around into an intelligible format, and then alert on it, whether it's you or workers in the field or even your customers or clients at that point, is what we're after. And from these things, you end up with expressions or extensions of this vegetation management, and from there even the ability to predict power outages is a piece of that. Now, to tie into what Jim has said already, the amount of data is growing, it's just proliferating. Weather data is a good example of that. What we used to do, 6-7 years ago in my career, human beings were very involved in trying to forecast maybe at the most 100,000 points, which was unbelievable at the time, globally speaking. And they would update that maybe 4 or 5 times with the help of some machinery per day. And now, what we have with artificial intelligence, machine learning, and big data computation, leveraging non-traditional sources of weather, including crowdsourcing type things, move that data to something that would be on your street corner, like a 500-kilometer grid square, 2.2 billion locations around the world, updated every 15 minutes. So, we've really moved to a new phase where the data has become so available, it's become so valuable. The humans now in my group are used in a triage type, environment where they can look to see if modeling is going well or going off rails, or they need to edit or modify in some way. But the heavy lifting is done by computation. Weather data has been a good example, a good case study for that. So, when you think about the topic of today, what we really are after is to try to identify or help a customer prioritize, where things are good and where things are bad. I'm specifically talking about the threat of vegetation infringement as it comes to power lines, and to be able to do this at scale. I'm talking about geographic scale. And the methodology that we have identified as the best way to do this is through geospatial analytics. If we can get a layer of the client's assets, let's call those right-of-ways, let's call those poles, whether they're metal, whether they're wood, and of course conductors or wires. We want to be able to overlay information on top of that. And then from that, to do analytics, which is the fancy word for math, to get to do the math on these things. And there's a lot of information that you can bring into that. This picture on the left is the best way to think of it. One of those layers has to be the client's poles and wires, right? In GIS in this case. One of those can be topography. One of those could be weather or environmental factors. Certainly some of them that myself and Jim are going to talk about are imagery based, whether it be from satellite or aerial or drone or LiDAR. And again, what the client is trying to solve is, can I get a picture of what's happening in my territory? Like, we like to use this word continuous. I think that's a bit arbitrary. For some clients, they would say, look, I've got no information right now. So if I could just have something even once a growing season that would tell me where vegetation is a threat and where it's not, that would be just critically valuable, right? But most of them are trying to solve this problem of insight, useful condition-based insight at scale, again, geographical based, with some level of frequency or recency, because this information can age out. For some that were blessed to do an engineering grade LiDAR scan, for example, years ago, 2-3 years ago, that's probably not as useful current day, right? And then to be able to get that cost efficiently. So the sources of imaging are becoming more optimized in terms of what you can get availability-wise, as Jim showed earlier, and to be able to get it with cost efficiency, so you can do what you need to do with gaining condition-based insight. So we like to show this stack, this idea of a stacked approach, right? There's several data sources that can be applied to help model or predict vegetation risk, from anything from open sources. A good example of that would, if you live in the United States, you'd be lucky enough to have what they call NAPE. It's an agricultural index sponsored by the government, an aerial image that's like 50 centimeters these days. It's gotten better over time. Problem just that it's updated every 2 years or so. High resolution satellite imaging or LiDAR. Our approach with this technique that we're describing today is to create a baseline, and then from that baseline to create a monitoring layer that goes on top of it. That monitoring layer can be a lever that we put in the client's hands to say how often. Is it monthly? As I said earlier, some people just once a year would be thrilled to have that. Others would say, you know what? Perfect would be at the beginning of the season and then again at the end to see how the work was accomplished or not accomplished, okay? And the nice thing is that the technology between IBM and Capgemini, we've gotten a lot of experience and we're flexible. We can use a variety of sources and we're good at working with the client to know what works under what conditions. Does it need to be satellite? Jim's going to describe some advanced forms of satellite later we'll talk about to meet some specific use cases. Does it need to be LiDAR? I'm going to introduce a new form of LiDAR that's come out that would also meet some specific and unique use cases. In some cases, the utility doesn't have assets in GIS that are in the right place. And between these companies, we can fix that, we can correct that. And of course, all the while, if we do a crawl, walk, run approach, when ready, we would bring in other context. Okay, not just tell you where vegetation is encroaching and it's a threat, but be able to tell you with more advanced variables where it's a threat with environmental factors like it's wet, it's windy, it's dry, it's a problem. So what I want to show just real quickly here is just a couple examples in case you're not used to this. With satellite as the source of imaging, one of the approaches is what they call spectral analytics. What we're talking about here is a picture. The left-hand side has one color band coming out of this picture. In this case, it's green or vegetation index. They call it NDVI. But spectral analytics is light reflection from what's happening on the ground. And you can see that there's a problem here. We can see what's a tree, but there's all kinds of things that are green in here: soccer fields, cars, rooftops. And we want to use analytics and AI to turn that into a useful set of data and transform it to what you see on the right, which is digital polygons that allow us to do the analytics, to do the math in terms of identifying where there's vegetation, how tall is it, what's the canopy size, and in many cases, even what's the species, because you can get things like leaf texture out of this spectral imaging that's coming back. So that's an example of using hopefully high resolution satellite, let's just say 50 centimeter resolution or better, to depict where vegetation is and where it's not. That's one technique. It's one of the lower cost ones. It's easy to get, and we've got experience in using that to create insights that we're talking about. When it comes to species in particular, what we're talking about is all forms of different species, right? People that are in California are going to care about different species than they would in Texas, than they would, say, for ash trees up in the Northeast and the East Coast, right? But if you think about it, it's almost like a heat map exercise where you're identifying species that matter because they're problematic. And ultimately to be able to render insight or an image that says these are the types of of species and where in your territory that they're at. I've got a customer, it's actually my power provider, that identifies species not just because of ignition sources, sometimes because they're fast growing. Sometimes it's just because the type of species is something that gets a disease that you have to push off until summertime and defer the work. So you can see it gets pretty advanced, but so species can be very helpful. Now I want to talk quickly here about a new form of imaging. And this is not engineering grade LiDAR. This is LiDAR that's built specifically for things like vegetation. We call it, or it's called Geiger mode LiDAR versus conventional LiDAR or linear LiDAR. This is a little bit faster flying, higher altitude type of aircraft and camera that uses a cone instead of more of like a single angle type thing that you would see with engineering grade LiDAR. As a result, you get a lower cost out of this, you get more data density, and it's going to enable all kinds of use cases that you're going to see us talk about here in just a little bit, and without that much more cost. It used to be that distribution networks just could not afford things like LiDAR, right? That's where the bulk of the mileage was for the power line, and they couldn't afford it. But nowadays, this is becoming more affordable, and it's extremely useful. And Jim's going to talk a little bit about the use cases, including increased accuracy, okay, with the results. But this is something that we've got a lot of experience in now that we really like. The point being that there's a lot of different sources of imaging that we'll use out there to try to advance this program above and beyond where you might see anybody else these days. So let me turn this back over to Jim, because he's going to talk a little bit about that.
Yeah, thanks, Robbie. I'd like to extend upon Robbie's message a little bit and sort of reinforce the fact that the EIS is this foundational tool upon which we can build all of these capabilities and applications. It's really quite limitless what kind of data we can ingest. And while there are advanced sources of data, we have at Capgemini and IBM a base offering, okay? And this is for analytics and vegetation management and for risk mitigation. What we do is we use a stereo pair of satellite images, and you can see the cartoon in the lower right. What it shows is that as a satellite goes along in its orbit, it images a spot on the ground looking forward. Then a little while later, as it's moved along in its orbit, it takes a second image of that same spot on the ground. And just as your eyes are separated by your nose and your brain uses those two images to create a 3D understanding of the world around you, we can use math and computers to do the same thing with these two different looks from a satellite. This really gives us a much increased ability to generate things like tree heights, tree locations, and other assets as well. The other aspect of our core, our baseline offering, is integrating this imagery with digital elevation models. Now, oftentimes our customers have DEMs, and we can import those quite readily, or we can find publicly available DEMs, or where the situation arises, if somebody needs to use a Geiger mode LiDAR to generate a DEM, that's very doable as well. But our baseline offering, it calculates better parameters, better locations, better heights, and a better understanding of the 3D world around your utilities assets using these types of advanced data and analytics techniques. Let's go to the next slide, Robbie. To extend a little bit upon the advanced data message Robbie was beginning to deliver, in the lower right, you'll see a LiDAR image. Again, basic LiDAR, but you can see how it maps out tree canopies very effectively. And we can use this type of data to identify individual trees from within a mixed group or a mixed clump. This allows us to get much better species information where that's important. And then the other aspect is hyperspectral data. And for those that don't know, your average camera, like on your cell phone, when you hit the go button, it takes 3 simultaneous images, a red one, a green one, and a blue one, synthesizes those on the screen, and you see what looks like true color, and that's great. But a hyperspectral sensor takes hundreds of images simultaneously, many dozens of red images, many dozens of green, many dozens of blue, and can even extend out into the infrared where the human eye doesn't work, into the ultraviolet, again, where the human eye can't see. But it's by using this extreme color separation of a hyperspectral sensor, we can get very superior object discrimination. And again, this doesn't have to be part of our baseline offering, but this demonstrates that EIS has this ability to incorporate any of these kind of data for even the most stringent customer requirements when it comes to species. One of our customers was asking us recently about elm trees. They wanted to identify specifically elm trees and to separate Siberian elm from American elm. This can very readily be done using these combination of technologies, and those results can be presented seamlessly within the EIS interface that Robbie's been presenting. Next slide, please. example of what we can do. And again, LiDAR and hyperspectral can be easily flown on any aircraft. The two technologies play very well together. They have the same kind of footprints, same power requirements, and you can do this very easily. An example of what we've done, I led a team not long ago which took LiDAR data you see on the left image. We segmented out individual tree canopies or polygons from that. In the middle image is a close-up of some of that. And then a little bit of a zoomed out image shows many tens of thousands of trees over a reasonable, about a kilometer sized area. We did this over a large area for the US Forest Service. We're able to identify about 500 million individual ash trees doing this. So the combination of hyperspectral and LiDAR, along with this ability to segment out individual trees, allows you to be very accurate in terms of classifying the trees. US Forest Service verified that the classification accuracy was everywhere greater than 95%, which is really remarkable for mixed stand forests. And the other thing that can happen is you can look at individual trees and not only grade the health or the moisture content or the risk of that tree, but you can actually map that across an individual tree, which can be very helpful as well. So let's go to the next slide. Yeah, so the upper right image shows the mapping of ash trees across a fairly significant area. Each of those squares is about a square kilometer. And again, there's probably about 1 million individual ash trees there. Again, the green, the white, and the ash were separated individually from one another. All other trees were ignored. And then the health status of each individual tree was given as a continuous variable, here displayed in shades of green, yellow, and red. And the other thing about this is the red trees aren't dead. In fact, if you looked at the red trees, they would look pretty darn healthy to you. You'd have a really hard time discriminating that they were sick. So this is a way of getting very accurate health information, even at the various early stages where a piece of vegetation, a tree or anything else is really starting to have problems. And then the image on the bottom shows hemlock trees. Everything black is other than a hemlock. And hemlocks are nice little conifers, so they're cone shaped. And you can actually see the health variation among and across an individual tree, where a lot of these will be green on the inside, yellow toward the periphery, and red on the outside. What happens here is the hemlock woolly adelgid infestation that was hitting the hemlock trees in this part of Pennsylvania attacks from the bottom up. So these conically shaped trees show a degradation in health on the outside first, toward the middle, and then finally they go up toward the top. So again, these types of advanced technologies, when linked with the analytics to pull this kind of information out, are extremely powerful. And again, when linked with the EIS, give us an ability to satisfy even the most stringent customer requirements here. Next slide, please. So yeah, we have a variety of advanced use cases that we can do with these specialized data streams. You know, even our baseline offering of stereo pairs with DEMs has an ability to calculate distance from any piece of vegetation to a conductor due to that 3D imaging and understanding within that EIS context. We can support things like directional trimming and detection capabilities. We can help you with asset location correction, because not every pole is where you think it is, and we can rectify these databases by determining the actual location from these. We can do things like measure and monitor over time, pole leaning and line sag. So that's good. And we can also do sway analyses with these. We can measure things like height of a line above water. Or, and again, when we get into more advanced data types, we can get very accurate tree height estimates, species determinations, and health measurements. So again, this can all bootstrap with weather data. And again, it's weather data on an hourly basis, a daily basis, a weekly basis, or even a seasonal basis to understand the true nature of the risks that your environment poses in and around your utilities corridors. Next slide then, Robbie.
Okay, great. Thanks, Jim. I'll take it up from here, because what we want to talk about now is, you know, we spent a bit of time describing the methodology, describing, you know, how we get around this problem that Jim framed up in the beginning of an overwhelming amount of data but to harness it in the right way, to make use of it, right? To get an insight that's going to provide value in the business context here. And so what we're showing here is the application, EIS, as we lovingly call it, Environmental Intelligence Suite. It's what it stands for. And this is what it looks like, you know, when you get down to the point of using the technology with the associated imaging sources we mentioned to do remote sensing and the AI and machine learning, ultimately to render, digitally speaking, where is the vegetation threat, the encroachment, and the vegetation that matters. What you're seeing on this screen right here is a color coding, and you see a little bit of what I'm going to talk about in the scorecard right next to it, which is identification of the feeders. I even have some customers that do spans, right down to the pole-to-pole level of which ones are a threat and which ones are not. Now, the scoring that you see in the scorecard here, just like in school, an A is good, or work that or maintenance that could be deferred. A B is pretty good. A C is not so good, and a D, like you'd get in trouble with mom and dad, you know, is bad. Okay, and so that's how this is prioritized, and that ultimately is what the first thing that comes out of this tool is a prioritization, and that's helpful when you've got a really big area. A lot of geography to cover, too much for your cycle. You're falling, you know, behind in your cycle based plan. Too much for your arborists, you know, to cover by themselves. This data can be used to augment the type of experience that you've got where you've got boots on the ground. But ultimately, if you could get a score like this across every feeder, every circuit section, regionally speaking, or if you wanted to get very localized down to the span level, that's part of the technology. Okay, and that scoring has never been the same amongst any two clients that I've got. Very typically, what you'd see is distance to conductor to drive that score, tree type or species in there. Jim went quite a bit into health. That would be certainly a part of the scoring. Volume of trees over a certain height within the right-of-way, or even fallen trees outside the right-of-way to drive this scoring and to get it across, you know, everywhere that you want to get. So it is custom. It's something that we work within our services piece of the business to make sure that that code matches what the customer says. Here's what's good and here's what's bad to me in my territory. Okay. Now, it's one thing to look at this, you know, on a map, and you know, we can do this for a few miles. I don't think for some of my customers, they've got 100,000 miles of right of way. You can't look at this, you know, just all day long. It is useful under certain circumstances. And so you want to be able to either export this via an API or use the application itself, whether it be here on your desktop or mobile, and get sorting capabilities or filtering capabilities. Now, I've got a customer that's here in Texas. Again, they're my power provider that uses this. They had, you know, just acknowledged that we can't keep up with the cycle that we've got. You know, we're falling behind. We really want to get to condition-based insight. And so when we started this program, it was a journey. And I would say that after a year now we're there, and what they do is they'll filter and rank across their whole network, all the D scores, everything that is a threat per se, and just filter by those, export those to their work execution system, and go after the D scores, right? It doesn't mean that they don't care, say, about the Bs and especially the C scores, okay, those that are also questionable getting bad. But they've got enough Ds right now that they bid those out, and that's where they go first. And as a result of that, network reliability is improved. Okay, so that's the point of showing this screen in the Environmental Intelligence Suite. So once we get to the point where we've identified the vegetation, we can calculate the canopy size, the tree heights, maybe the types or the health of the thing. At some point, you're going to want to bring in environmental factors, right? So now we're going to combine tree heights and tree density, tree encroachment, we could call it, with other environmental factors. How wet is it in the ground right now? Because I know this tree that I have to deal with all the time falls over when it's wet enough. Now, there's an analytic or a math number that says on average, when this tree type, this species, of this wetness or moistness combined with the wind from a certain direction, a certain duration, is going to cause problems. It's going to cause fall-ins or fall-overs, and it's going to cause outages. Now you're seeing us move into the more advanced cases where environmental factors are at play in the Environmental Intelligence Suite. Okay, and so that's a capability that we bring to the table here, and we have expertise in. So I wanted to show real quickly then the idea of the combined effect of the Environmental Intelligence Suite as this what we call integrated experience. Okay, so on the top, you can arrange your what you're looking at here, your dashboard, to be like just your severe weather dashboard. I need to know across my territory, circuitry combined, okay, all your assets plotted here on the map if you'd like, where things are okay, where they're not, and what the latest storm is doing, and setting up alerts, for example, if you want to, all across your territory. On the bottom left, this is what we've been talking about, your vegetation insights, all the way down to the span level if you want it, or at the corridor or feeder level, and then score those, okay, with the latest remote sensing with what we've talked about. Bottom right, we'll take it one step further. Now we've got weather, we've got the vegetation insights. Now we can do the model, and we have this model as well, to predict when and where power outages are going to happen and the recommended mobilization level in advance of the storm so that you can get an advanced step on the storm. Power would go on faster. Hopefully you'd minimize the time or the duration, the number of minutes that a client is out. And that's part of the integrated suite of the Environmental Intelligence Suite. Okay. So I think this is a good place to transition to kind of our culmination slide. I'm going to turn it back to Jim to kind of summarize where we've taken you through today, and then from there we'll take questions.
Yeah, so here we just summarize what the EIS combined with advanced GIS analytics and vegetation management can do. To me, the EIS offers this amazingly comprehensive, scalable, and flexible environment. It's a tool that works really well, and it allows us to organize things, control things, and oversee vegetation management operations. Very, very useful. Our base offering, as an example, derives superior vegetation heights, distances to conductors, and other metrics that are important to the customers, and also derives species information from the stereo pair imaging and digital elevation models that are standard in that baseline offering. It's key to reiterate the message that the base offering is configured to conform to each customer's specific data, priorities, and KPIs. As Robbie said, no two customers are the same. So what you mean by priority isn't necessarily the same thing as your neighbor means by priority. And the EIS is built to be very easily modified. If you even change what you mean by priority or accuracy, we can implement that change very rapidly and have it to you in very little time going forward. Very, very nicely extensible system that way. Then the growing availability of and cost effectiveness of various types of geospatial data, whether it's satellites or drones, is an amazing opportunity to extend nearly endlessly on this baseline offering. You know, LiDAR and Hyperspectral together can be used to derive the highest quality results for tree species health mapping, height metrics, and giving enhanced functionality to the EIS. And again, our end-to-end vegetation solution can reduce the time and cost of your operations and greatly reduce risks as we look at the vegetation, understand how risky it is under various weather conditions, both presently and as they've happened in the recent past, the dryness and soil conditions and so on. So this is really good for your infrastructure and for your customers. And that's basically our takeaway. So the next slide. Robbie and I are both more than happy to field questions now and to take any inquiries via email. You see our addresses now. And what we'll do is we'll transition to the Q&A portion of this presentation. Thank you all so much.
Hello again, guys. Thank you for that presentation. That was really informative. And we've got questions coming in already. So excited to hop right in and pose them. First one, can ice buildup on transmission lines be monitored? It's a big issue apparently for utilities in Canada.
Yeah, I can, Jim, I can take a shot at this first one. You know, in terms of monitoring, you know, the program that we've got here will include that. If that condition is happening, and that's part of the, say, the weather modeling, you know, if you've got radial ice in particular, you know, or not, I mean, how much is forecasted, et cetera. So that can be incorporated, and it's not so much a detection. So we're not, in this case necessarily pitching that IBM or Capgemini has IoT sensors that are going to tell you if you have ice and how much. We do predict how much there is intended to be. If you've got, measuring data for that, we can incorporate it, I guess, is kind of the spirit of the message here, and, predict where you're going to have the most problems. Okay. Jim, would you add anything to that?
Yeah, well, what I might try to say is, however one has models that can do prediction of the amount of ice on a conductor, it's a classic data science and machine learning tool or use case. Basically, however good those models are today, we continually retrain the model going forward, train it again and again, and as time goes on, those predictions get better. So again, it's sort of the weather conditions inside the EIS measured regularly every 15 minutes, getting predictions going forward. Those things can really help us measure these things, understand these things, and make these predictions. So that's doable today, and it will only get better as time goes forward as we retrain and refine the machine learning and analytics models.
Thank you both. And to our audience, please keep sending the questions. We'll keep answering them. We've got about 15 minutes left. Can you guys discuss how this works with my existing data investments, or how does it complement my existing GIS?
You want to go first, Robbie?
Yeah, I mean, you can probably expand, because, Jim his specialty is how do you handle the proliferation of all this data that can be useful if you can get your arms around it and unpack it. I think that the question included a reference to GIS. GIS is one of the preferred methodologies to get to doing these kind of analytics that show across a customer's network, where things need to be paid attention to and where they can be deprioritized. What that part of that means is, that is data that's coming from our customer. So a customer's existing data investment in GIS is really important. A lot of people struggle with, we'll just say, data accuracy with where their poles and wires are, especially on the distribution side. You don't see it quite as much on transmission, though it exists there as well. Because in order to do good mathematics, to do good analytics, we need to start with the known location of, poles and wires. So we have ways to correct that if the client, is struggling with that. But that's an example of, information that we need from a customer so that we can add value to that, right? I mean, a lot of times that GIS data sets that would come from a client or include all kinds of useful information, including things that you could incorporate into your scoring, voltage type, for example. Does it have a switch on it or not? Is this, segment have, is it got transformers or not? Those are all, information that can come as part of those data sets that can be included in prioritizing or deprioritizing different segments.
And for me too, this is one exciting area, and one of the reasons I'm so delighted to be working within the context of the EIS is the way it's structured and the architecture of the system. There's virtually no limitation to the type of data it can utilize. I haven't seen or I haven't dreamed of a data type that we couldn't utilize within this framework. So just as a simple example, a customer may have spent time and money collecting LiDAR data already. Well, those are easily importable into our systems and can be leveraged to derive superior information products going forward. You might have spent time collecting aerial imagery, or you might have other information. For example, classic one is just your pole locations and other asset information from your GIS system. So those are all readily importable into the EIS. And then the other nice thing about it is it goes backward as well, because as we develop information and populate the EIS for you as a very handy and useful front end, all of that stuff exists within a GIS context that lives inside the EIS, and you can readily export any layer or any number of information out of the EIS and utilize that in your homegrown GIS system. So that's one of the exciting and most flexible aspects of what we're doing here.
Excellent. And you mentioned LiDAR, and that really taps into a next question, which is, You know, LiDAR and hyperspectral sound great, but they might be expensive. Are they required for this solution?
Why don't I do that one first, Robbie? We've designed the baseline solution using stereo pair satellite imaging and digital elevation models and all the other data that any customer brings to the table. We've designed that so that we think it'll satisfy the vast majority of customer requirements. So realistically, the baseline solution is all that most folks are going to need. There are folks that come to us and say things like, well, what about elm trees? What about ash trees? What about fire risk? How dry is this piece of vegetation? If you need higher accuracy solutions, we can go forward and augment the baseline solution in a way that's most cost effective going forward. And the other thing I always tell people about LiDAR and hyperspectral is the two technologies play really well together. If you're going to spend the money collecting LiDAR data for this, that, or the other thing, go ahead and slap a hyperspectral sensor on that same aircraft or drone. They don't cost that much. The increase in cost will be nominal, and the strength and power within your data will be enhanced orders of magnitude. Because as you can see from what we've talked about a little bit, what you can do with the combination, what you can do with LiDAR is great. What you can do with hyperspectral is amazing. What you can do with the combination truly takes things to another level. So.
Yeah,
Anything to add to that?
Well, yeah, it's a good point. I don't think I can add too much to that. I think Jim framed that really, really well. That the platform is flexible. The imaging sources have a lot to do with those, some of those buckets I mentioned earlier. What are you trying to accomplish? What's your set of use cases? What's the scale you're trying to cover, geographically speaking? What's your budget? I think the question insinuated that LiDAR and hyperspectral is too expensive. And that one of the modes of LiDAR that I mentioned today that's fairly new, this Geiger mode LiDAR, is a fraction of the cost of what I think most utilities are accustomed to hearing for LiDAR costs that are engineering grade type LiDAR. So you really can use this for vegetation, detection, for poles and wires detection, pole lean, line sag, all kinds of expanded use cases with even just a little bit more investment. So I would actually dispute that they're too expensive. I think that they are very much in reach, commercially speaking. If you looked at the return on investment that you get from them, it's present.
The other thing I might add too about cost, years ago in the field I was in, I built the world's first terabyte RAID system for storing data. And I thought I was pretty cool because I had a terabyte of RAID storage. Nowadays a terabyte of storage is nothing. That thing cost me over $10,000 to build. And nowadays I just bought a 4 terabyte disk for less than $100. So whatever LiDAR cost 2 years ago, the costs today are way less. They're going to be way less a year from now. Just as with every other data type, the costs are going down. The effectiveness of pulling information out of the data is going down, and everything is just getting much more efficient. So that data-driven, condition-driven vegetation management capability is only getting more and more real, only getting more and more operationally viable.
Great. We've got a few minutes left. I want to get to a couple more questions we've got. So we're hearing from folks who are looking at developing these kinds of solutions in-house. Can you talk about how what you're offering is different than what they could do themselves and why that it's a valuable difference?
You want to go first, Robbie?
No, go ahead, Jim.
I mean, look, you take a good team, you give them enough time, they're going to develop a system that's almost as good as the EIS and the baseline solution we're talking about. But you have to recognize that years and years of development have gone into this. IBM has spent an enormous amount of internal resources developing iteration after iteration. And I don't want to say that, they've made mistakes, right? But, Murphy's Law always teaches you new things, teaches you where to solidify and how to go forward. These things are available today and will only get better over time. And the other thing that I think is unparalleled in this offering is just the granularity and the time sensitivity of the weather data. I don't think anybody can beat what IBM can do with the weather company, going forward with weather data. And we have a team of over 500 data scientists and analytics experts within Capgemini dedicated to supporting this effort. That team is more than capable of producing better results 6 months from now, 12 months from now. So yeah, an internal team can develop things and make things go, but this is essentially ready. Maybe not shrink wrapped, maybe that's a little bit optimistic, but I think you'd be amazed at the maturity level and how really ready out of the box we are to go.
Again, I wouldn't add too much to that, but to say, as over the years, if we've watched people, the reason that we have customers of this is that it is a little more difficult than you think. This is not just, hey, I got an image and I slapped it on top of our assets and Esri, and we can support it going from here. That it is much more advanced than that. Specialties in GIS, specialties in artificial intelligence, specialties in machine learning, and of course the handling of really large data sets, and to be able to curate those because they're not always ready to go, and to have a platform then that's supported 24/7 that propels the advanced stuff, like where you really want to get to, not just here's where my vegetation is and here's where our assets are, but to combine the things that Jim was mentioning. I mean, even something that sounds as simple as like a wildfire layer, or where are we going to have our next flooding event, combined with all these vegetation areas that we're concerned about. That gets to be sophisticated. It's more than the average shop can take on. That's what I would say.
Great, and it makes a lot of sense. You guys have done all this learning. People might as well take advantage of it. You spoke in your presentation about condition-based vegetation management, and so why should folks switch from cycle-based vegetation management to condition-based?
I'll take first shot at this one, Jim. We are hearing more and more utilities that are kind of throwing up their hands and saying, look, cycle-based, that is the traditional way of handling this, right? And it's a reasonable approach. You go back to an area every 3, 4, 5. I mean, I've heard it as long as 14 years before going back, to an area for maintenance, conditions. The problem is that Mother Nature doesn't work like that. Vegetation doesn't behave like that, especially when you mix it in with environmental factors, humidity, moisture in the ground, trailing precipitation, that kind of thing. And we've got utilities that really would want to move to condition-based insights if the information were trustworthy enough. My power provider I mentioned earlier in this meeting is one of the first that I know of that has completely moved away from cycle-based maintenance because they were falling behind, right? They couldn't keep up with the money they've been given, the amount of time that they have to conduct the maintenance. And they've moved to, that simple exercise I mentioned earlier, which was exporting the D scores, the scores that are bad across, really thousands and thousands of miles of network. And their network reliability has improved as a result. So, why would people do that? Because it's going to improve network reliability. It's going to reduce your costs. You're going to be more effective as a department.
Yeah, and then to add to that a little bit, this is the classic foundational reality of data. And again, it's across every vertical that we see inside the data science and analytics group here at Capgemini, is data when done right simply makes things happen faster, cheaper, and more efficiently. And so I was talking to somebody in another industry some years ago, and she basically said, because we're more efficient now, I can set my creative people to being more creative now than doing more grunge work. So as they were monitoring things in a very manually intensive process, taking days to do things that now take minutes, all of those creative people within your organization, all of those talented people can now be doing things that add additional value. So again, to me, it's all a matter of the efficiency of an organization and then what you can do with the monies that come out of efficiency or the save time that come out of operational efficiency.
Well, we're about 2 minutes out from the end, so I think we're going to wrap up. I want to give you guys each a chance to share any final thoughts before we end the webinar. And Robbie, I'll come first to you, and then Jim will let you have the final word.
Okay. Yeah, no, it's a real honor to get to talk and to present today. You know, between the two companies, between IBM and Capgemini, we've got a lot of experience in doing this. You know, we can take a complex problem and create useful insights that are going to solve, you know, real problems right now. That's what I would say about this. So we'd love to talk to you afterwards. If you want to talk about this, we could set up a session. It's typically how it goes, and in some cases even, you know, take a test area to put this to the test and show you, demonstrate to you that it can work.
Yeah, and I guess for me, I'd say just I'm super excited to be involved in this. Like I said early on in the introduction, I've been doing vegetation stuff for a lot of decades, and the improvements in data, the improvements in computers and methodologies, what we're doing now is just so many, many light years ahead of what we've done even a few years ago. So this marriage or partnership between Gemini and IBM really offers this very mature capability going forward. And again, I'm just super excited to be taking part in the development of this baseline capability. And then again, as customers come along and need enhanced capability, services, product information, it's all there for the taking. We've got the teams to do this. We've got the experience to do this. It's just a really exciting time because just data is making everything take off.